Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to get started with a small mini series to cap off this entire JavaScript in-depth series with a topic that is near and dear to my heart. Something that is really just fun to talk about and build, but actually kind of strikes fear into a lot of especially newer developers, and that is object-oriented programming. So those three words definitely strike fear into my heart when I was first learning programming. Just a little fun fact, when I had my very first technical interview, I was asked a series of questions about this particular topic, and I messed them up so badly that to this day, I pledge to help as many people as I can to and not make the same mistakes that I did and feel as awful as I did. Hopefully you will have a bit more oomph to your answers when you can actually go through content like this and be ready for things like that in an interview, as well as these concepts in real life as you start programming your projects. So I'm super excited to get to this. We're going to probably go through a few videos, starting with an intro in this video on this topic since it's so vast and so deep. We're going to cover as much as we can so we can actually start using this idea of classes and the class syntax in JavaScript, as well as objects, to make it a bit easier to organize certain parts of our code. And I'll mention where it has a lot of pros, as well as maybe where it has some cons as well. So without further ado, let's get right to object-oriented programming. Okay, so to start, I just want to kind of go over some kind of high-level concepts before we start diving right into the code as usual, just so that we can kind of get our heads wrapped around what it is we're even trying to learn and why this is even important or useful for us, right? So to kind of start, I just want to mention that this object-oriented programming thing is really just one of several programming paradigms. All right, so that's just a fancy way of saying that there's many other ways to program other than object-oriented programming. Object-oriented programming is just one style of programming that kind of fits a lot of problems, but not all problems. In fact, there are definitely people who absolutely despise object-oriented programming and don't want to even touch it with a 10-foot pole because of all the kind of cons that it does come with. So there's definitely pros and cons to it, and there are use cases for object-oriented programming, but it's not always a thing we need to reach out for. It's just another tool in our tool belt, and JavaScript is dynamic enough to allow us to actually bring this in only when we need it without having it to be such a central core part of the language, like in many other programming languages. So to start, it's important to realize that there are other types of programming other than object-oriented programming. So for example, one of the most popular styles, and one that I love very much as well, also very near and dear to my heart, is functional programming. We've actually seen this already, right? When we do things like, for example, map and filter and reduce and stuff like that with our arrays, that is actually a functional programming style. This is totally different from object-oriented programming. In fact, it's kind of built to supplant a lot of the cons of object-oriented programming. However, pure functional programming is definitely quite challenging and sometimes even not really achievable in production applications. So it's nice to be able to mix and match these different concepts together. There are many other styles as well, like logic programming, event-driven programming, symbolic programming, all this kind of stuff. But just so that you know that object-oriented programming is just one of these styles, and it's not the only one, and not the only one we'll ever end up using, but just a very common one. Okay, so now the most important thing to keep in mind when we're learning object-oriented programming for the first time is really these two concepts right here. So in object-oriented programming, in fact, in all programming in general, the hardest thing to do, and the thing that we spend the most amount of time and effort in our debugging and late night sessions and things like that, usually revolves around this idea of managing state. Now that sounds kind of weird because what is state, right? But effectively, state is just data for our application that is organized in specific ways and needs to be updated and changed and managed, right? And to do this, we can do it in many different styles. So object-oriented programming is just a style or a set of tools to allow us a new way to think about and to manage this state. Functional programming does it very differently and has its own kind of methods. In fact, it tries very hard to avoid as much state as possible. So when it comes to object-oriented programming, though, it really is about the interactions and the modeling of these states. So the state can kind of work with itself and work with other states. And then when they talk to each other, we need to figure out how they can do that and what that all means and have some kind of structure around all this. Okay. Now this all just seems very vague and arbitrary, and it's kind of like I'm not even talking about programming at all. But I promise you, as you start kind of going through this concept, hopefully this will make a bit more sense, and I'll try to bring it up in the context of state specifically, because this really is a central part of object-oriented programming. So to do this, object-oriented programming implements this idea called objects. We've seen this in JavaScript, right? We have objects in JavaScript, and I'll mention that other programming languages actually don't, and kind of that changes the way that we have to do things in some other languages. And the whole point of OOP, or object-oriented programming, is that these objects have data and code associated specifically to them. Okay? And we can group these objects together, and we can talk about objects in a particular way, which is different from other types of objects. And this whole concept is structured in a very particular and neat way that allows us to kind of holistically call this thing object-oriented programming, which works across all languages that support it. It doesn't only work in JavaScript. Okay, so let's kind of set this up a little bit better. So I want you to imagine that we want to program a game. Okay, so like a fantasy game. If you've played one of those before, there's many of them out there, or really, frankly, any type of game. I'm just going to go the fantasy one since I've played these myself and they're pretty fun. So usually in any game, we have something like players, right? So usually maybe it's one player, maybe it's many players. And in some of these games, you can kind of choose what kind of player you want to be, right? Maybe you want to fight with a sword, or maybe you want to fight with some magic, right? So maybe, for example, our game, we can have different types of like player classes, okay? So we might have like a warrior, we might have a wizard, we might have a bartender, right? It fights with mugs or something, right? It doesn't really matter. The point is that there's many styles of players that we can actually work with. Now, similarly, the same can be true for enemies in our game, right? So we want something to be able to maybe fight against and get experience from and level up and all that kind of stuff. So maybe we'll be fighting like enemies, but all the enemies kind of share some traits. And maybe there's like orcs, and then there's dragons, and maybe there's like a very scary fish, okay, in our game for whatever reason. All right. And so maybe these share some traits, just like the players all share traits and the classes share traits and things like that. But some things are specific to an orc, some things are specific to the very scary fish and the bartender. Okay. So I want you to think just very, very high level, right? If you're thinking about modeling this application, very similar to how we looked at modeling, for example, Pokemon or our deck of cards in previous projects, how would you actually think about and model the stuff that's needed to create these players and these enemies? All right. So while you have that at the back of your mind, I want to go through a couple more big concepts, and then we're going to come back to this. And in fact, in order to actually really dig into this problem, that's what we need the other videos for as well. So we actually need to cover the introduction as well as other concepts like inheritance and polymorphism and all these fancy words, which I'm going to get to next. So the main ideas of object-oriented programming. And this is, for example, one of those questions where I was asked, and I think I flubbed it a whole bunch because I couldn't really explain each of these in depth. It's really built on these 4 pillars, and this is across every programming language that supports OOP. Okay, we're going to cover most of these, and I'll mention in a second which ones. So we have inheritance. Okay, we are definitely going to cover this. This is a pretty important and big part of object-oriented programming. We have encapsulation. This is definitely an important part and something that we actually can do without technically classes specifically. We can do this in other ways with JavaScript, but the class syntax makes it a bit easier, and we'll see this in action as well. We have something called abstraction. Now, this is a bit trickier to implement in JavaScript, definitely possible, but the language is not really built for this from scratch. There are ways to hack around it and make it work. But for example, other languages like, say, Java and C++ and things like that have abstraction, which allows them to create these things called abstract classes and abstract methods and all this kind of stuff that's abstract, which will make more sense when we get to this concept of inheritance. okay, and in classes in general. So we're not going to cover this as much. However, I will mention parts where it is applicable and interesting and important. And if you do want to implement this in JavaScript, there's definitely ways we can do that. I can maybe make a couple exercises for this, but also something called TypeScript, which is a typed version of JavaScript, really makes a bit of that automation to actually deal with that in JavaScript a little bit easier, and it does support abstraction at a very high level. Finally, there's polymorphism. Now, this word is very fancy, and it makes you sound very intelligent when you say it. So if you go up to someone, and a programmer or non-programmer, you say, I know polymorphism, you sound extremely smart. But all this is another kind of main idea behind OOP, and is very, very powerful concept, and we're definitely going to get into this because it also has to do with inheritance and how we can kind of treat many different objects as like almost the same kind of object, which will be very useful, for example, if we treat all enemies as sort of an enemy, even though they might be slightly different from each other. So we'll definitely see these in detail in the upcoming sections. Okay. So before we actually see some code, I want to kind of touch on this because it is very important and often skipped. JavaScript is not a traditional object-oriented language. All right. It has objects in it, and it even has this class and object-oriented programming syntax that we're going to see together. However, at its core, classes in JavaScript and everything in JavaScript is built on top of prototypes, which we saw in the previous videos. All right. So technically speaking, JavaScript is a prototypical language or prototypal language. I always mess up those words. And we can do things like inheritance, for example, but that's technically prototypal inheritance, not like traditional class-based inheritance. For really traditional OOP, you would be looking at languages like Java or C++ and things like that. It's definitely not every language. However, it's pretty much good enough in JavaScript to get most of the things that we care about done practically. So it doesn't really matter. A lot of this is a little bit of pedantics. So what's also interesting is that in JavaScript, we actually have objects as a type. So we have curly brackets, for example, and we have keys and values, which we've seen. A lot of other languages, especially these traditional OOP languages, like I mentioned, Java, for example, they don't really have this type. All right, so you can't kind of just do like curly brackets and put a bunch of stuff in there. They're much more strict than that. So they actually really only have this class idea, which we're going to look at shortly, to create these objects. But we're also going to see that technically it's pretty much the same thing. All right, when we're creating classes in JavaScript, we're basically just creating objects anyways. So really it is just kind of semantics, and they're the same thing behind the scenes. So the most important thing is that we can basically simulate OOP concepts in JavaScript, even though it's not an actual object-oriented language, it's a prototypal language. Okay, so definitely keep that in mind as we go forward. All right, let's get to some code because I'm sure we're all here for most of that. Now, let's take our example that we saw earlier, our fantasy game. Okay, and let's say we want to allow people to create players, right? So one way that we could do this is like I have here on the screen, right? I can create an object that looks like this, and maybe it is called player, and it has these curly brackets, and maybe we put a bunch of key value pairs in here. So for example, name, and we don't really know what the name is yet of the player, so we'll just put a placeholder, right? Maybe question mark to start. And we could put null, doesn't really matter. We could have an HP, which is like their health points, and start it at some default value. Magic points, if they have any, maybe start it at 0 or some other default value. Maybe each player has items, that kind of makes sense. And maybe it's an array, right? Because you can usually have many items, like maybe you have some bread, maybe you have a sword, right? Many different things that you might have in your bag, for example. Now, let's take a look at how we might actually create players, because this is really just like an empty player. Like this doesn't really mean anything. This is more like a template for a player, right? Like we want to be able to create many players. So if we want a player 1 or a player 2, or we want to give a player a different name, they should all be able to create their players, and it should just kind of work, right? We don't just want one player object. So maybe something we can do is something like this, right? Maybe we create a player called Han Solo, and we assign it to player. Okay, and then we create another player called Darth Vader, and then we assign it to player, which is our template as well. Now, we're going to code this, but before we do that, I'd like you to take a look at this code and really sit and think about why this is really bad. Why is this not going to work, and why are we going to run into issues with this code in particular? Okay, so I'm going to pull up VS Code, and I'm going to create a new file here, and I'm just going to call this bad intro.js, I guess. Couldn't really think of a name on the spot, but let's just go with that. I'll zoom in a little bit more just so we have a bit more space, so it's a bit more visible before I bring up the terminal. So let's say we have our const player, and this is going to equal an object, and maybe each player has like a name, so maybe a question mark. Each player, let's take a look here. It has some HP, maybe we start like 100, some MP, maybe 0, and then items, which was an array. Right? So let's start with Han Solo. So let's say we have Han Solo is equal to player. And then if I console.log out our friend Han Solo, let's see what we get. So I'm going to pull up my terminal here. And I'm going to run, make sure I'm in the correct folder. I'm going to run node bad intro, I guess is a very weird name. Okay, like that kind of works. That kind of works. I mean, it's the default values, but that's what we want. We want to be able to change them. But before we do that, let's actually create Darth Vader as well. So we'll say const Darth Vader is equal to player as well. And I'm going to also console.log out Darth Vader. All right. Then on clear our console, I'm going to run this again. There we go. Okay, so we have 2 templates, right? So that's pretty good. Looking pretty good. Let's modify Han Solo to start, right? So right after we create Han here, let's give Han Solo.name is equal to, let's just say Han Solo, right? And then we'll do Han Solo.hp. Maybe he has less HP, like he usually tries to get out of things pretty quick. So maybe he actually has like 80. Han Solo.mp, right? Maybe he has like 20. And then a Han Solo.items. And maybe he has, I think I gave him a blaster, just like he has in the movies. All right. So that's pretty good, right? This kind of makes sense, right? So if you think about this kind of is logical, right? We have a player object and it's a template. And then we have a particular player in this case, who is Han Solo. And we're assigning Han their name, HP, MP, and items. And then we try to create Darth next. And Darth Vader is going to have their own set of name, HP, MP, and items. But let's run this code real quick. So we want Han to have all the stuff in there, and Darth Vader should be empty. Oh, okay, right? So hopefully you saw this issue when I kind of prompted you to think about the problem with this code. So why is Darth Vader the same as Han Solo, right? So the answer is that player is an object, and objects in JavaScript are just references. We only have one type of this thing that exists at a time. All right. So when we're modifying Han Solo right here and changing the name, HP, MP, and items, we're actually changing our template over here. All right. So when we actually assign Darth Vader to player, it's already been modified with these values. So this is not really going to work, right? We need a better way to create these templates. So you might be thinking already, oh, there's, all these other different methods that we can create, object.create and all these different things. And that's true. And we're going to see that in a second. And I want to kind of just start by looking at how this is already kind of problematic. We just need a better system. There's many solutions to this, and we're going to start building our way up to classes as a final solution. All right. So now that we've seen that this is bad, let's go with this example right here. So I'm going to propose, okay, this is just one way we can do this, is that we're going to create a function, okay? And this function is actually going to take as arguments the name, HP, MP, and items. And we're going to return an object that has all those things in it. Now, this is the short form syntax right here for assigning properties to an object where the property names match the thing that we're assigning it to, right? So I'll show you that when we actually code it out, but hopefully that makes sense. And we're going to return a new object that's constructed with those values, right? So for example, we could say Han Solo, and we're going to call our create player function, which is effectively going to return to us our template with all of the values assigned accordingly. So we can pass to Han Solo all those values that we had, and then we can pass to Darth Vader separate values. And each of these players will have their own state. Okay, Han Solo will have his own name, HP, MP, and items, and so will Darth Vader. Okay, so let's code this out together. So I'm going to create another new file. I'm going to do slightly better .js. And in here, I'm going to say const create player. And this is going to take a name, HP, MP, and items. And we are going to return. So I'll show you the long form of this, and then we'll just do the short form just in case you haven't seen this syntax before. We're going to assign name to name, HP to HP, MP to MP, and items to items. And as you can see, we're returning this object directly. We're not putting it into a variable and then returning it. We're just returning it right away. Okay. Now you're probably looking at this and be like, okay, like this is kind of weird. Like, why are these all the same? So in this particular case, where the name of the thing that we're assigning to the property is the same as the variable name, we can actually get rid of the second one. And JavaScript is smart enough to kind of figure out that those are going to match just like that. Okay, perfect. So we can shorten it a little bit like that. So now we can say const Han Solo is equal to create player. And inside of here, I'm just going to put this on multiple lines just so that it doesn't run into my terminal on the right side. We're going to say Han Solo, and then we're going to pass in, let's just say 100, and then 10, and then let's just say, blaster. Okay, and then it's going to, Prettier is going to put that on one line anyways, which is kind of annoying. But let me just close my terminal for now. All right, and then I'm going to say const Darth Vader is equal to create player. And let's just say we do Darth Vader is the name. And then the HP, let's just say HP is like 200, for example, and it has got more MP. And Darth Vader has a saber, right? Lightsaber. And we can console.log out Darth Vader. Okay, so that's pretty good, right? That kind of seems to make sense. This is a function, just like any other regular function. And then we can call the function, and it's going to give us back an object. And this object is going to be a new object for each instance of these variables. So now, if I bring my terminal back and I run node slightly better.js, look at that, right? That's pretty good. We have an object, and each of these objects has their own state. So now if I change something in Han, so for example, I say Han Solo, maybe I'll do this before the console log, and I'll say .hp is now equal to 150, for example, right? I am not going to be changing Darth Vader's HP. I'm only changing Han Solo's HP, which is pretty awesome. Cool. So now there is some issues with this, right? So I'd like you to think what the issues might be. This is a hard question to answer because we haven't really seen how we can improve this and why we need to improve this. But I'm going to kind of propose to you just a couple of issues. Now, one is that these are all just regular objects. Okay, so if you think about this being a player, like with our thematic of it being a game, a fantasy game, this is kind of awkward, right? Because I would like to be able to say that this is like a player, like be able to give it like some kind of tag that's a player and have it be different from just a regular JavaScript object, right? I'd also like to be able to attach stuff to it, maybe the prototype, without messing around with the regular object prototype in JavaScript that everything in JavaScript is using. Right? So you can probably think that, okay, like we can kind of modify this a little bit so that there's, some objecty stuff in here where we saw that we can create a new and then use a new keyword with functions and things like that, right? So let's kind of hold on to that thought, and we'll come back to that shortly. I want to show you that we can actually automate a lot of that, and we'll do it both ways in a second using classes. So classes in JavaScript are really a way to automate a lot of this prototype stuff and do some of the stuff I just mentioned, where we can create our custom objects just like this player right here, but not have it be the object prototype, for example. We can still have it link in the prototype chain to the object prototype, but we can have it be customized so that if we add stuff to it, we're not messing up other things that inherit from object in JavaScript in general. So let's take a look at what that looks like with the class syntax. Now, I should mention that this is relatively new to the language as of, I think, like 2015 or 16 or something like that. So relatively quote unquote new. A lot of frameworks and tools that we use kind of take this code and turn it into the function version of this code behind the scenes so that it can work in older browsers. And I'll show you both versions, at least a simple version of both versions, just so we can see what that actually looks like. Now, this syntax is what we want to do when it comes to object-oriented programming in JavaScript. We have a new keyword. This is the class keyword up here, right? And you can see that in this case, it's not like a function. It doesn't have regular brackets after it or parentheses after it. It just has directly the name of the class and then the curly brackets, okay? And traditionally, what you want to do by convention is name the thing for the class in uppercase letters for like the first letter of the word instead of in things like camel case. That usually is just a convention to show that this is really a class. Very similar to object is an uppercase O, date is an uppercase D, array is an uppercase A, etc. Okay, so we can differentiate between a class and then instances of the class if we use camel case later. Now, the interesting part of classes comes with a constructor. But before we even get to this, I would like to show you something really, really cool. So this is what I wanted to promise to show you, which is basically doing this, but before we actually see it work with classes, now that you've seen a bit of this syntax. So I'm going to create a new file. I'm going to call this manual class.js. And inside of here, what I'd like to do is I'm going to create my class and I'm going to call it player. And I'm just going to add some curly brackets after it just like this. Okay. I'm not going to add any of that constructor stuff. I'm not going to add anything else in here. I'm just going to directly do const Han Solo is equal to, and then here is the important part. We need to use the new keyword and then the name of the class, and then we call it like a function. All right. And now if I do console.log of Han Solo, and I run my node manual class.js, you can see that we have this tag that shows that it is not a regular object, it's actually a player object. And it's empty because there's nothing in here yet. We haven't really added any values. That's pretty cool, right? And just to show you the difference, if I console.log out a regular JavaScript object, I can't get my brackets right today. What we're going to see is just the brackets, right? So we want to be able to tag these and show that these are not regular JavaScript objects. These actually have them in the prototype chain, so they inherit from object, but they're our own custom object. All right. Now, to show you something else, I just want to do this as well. I want to do a console.log of object.get own property names. That's the one for Han Solo. Okay. And I'm going to clear my console. I'll run that one more time. So you can see that there's nothing in here. Okay. So Han Solo has no properties right now. So that's kind of interesting. I'm going to copy this line and I'm going to close my terminal real quick just so you can see this. I'm going to check Han Solo's prototype by doing __proto. Oh my goodness, I can't type. Just like that. Okay, so this is the instance of the object, which we created here on line 3, and we can ask for its prototype in the prototype chain. All right, so if I run this, we can see that it has a constructor in the prototype. So that's kind of interesting, right? Oddly similar to this name, right? So let me show you what's really cool about this. I'm going to create another function and we're going to simulate this with vanilla kind of JavaScript without the class syntax. I'm going to call this function, let's just say another player. All right, this is going to be a regular function just like this. Okay. And the difference is we're going to leverage the this keyword inside this function and be able to leverage the constructor using the new keyword and actually set up the this context for a regular function in JavaScript like we saw in the this video. Now, in here, I'm actually going to ignore that for now because I don't actually have anything set up inside of player yet. But once we add it, we're going to simulate that this keyword inside here as well as in here. So really quick to start, I'm just going to say const, let's just do Darth Vader is equal to a new another player. Okay, and if I do a console.log of Darth Vader, let's see what we get. Clear my console here, run it one more time, and then we get another player. So that's pretty cool, right? So this is not a regular object anymore, right? We saw that with the new keyword, we actually get a object that is tagged with that name that actually points to the object prototype as this prototype. So what I'm going to do now is I'm going to do the same thing here. I'm going to copy this code where I'm grabbing the prototype names for Han Solo and Han Solo's prototype. And I'm going to replace Han Solo here with Darth Vader, right? So this same code, we're going to look at Han Solo's and Han Solo's prototype up here with the class syntax, and then Darth Vader and Darth Vader's prototype with the function syntax. And keep in mind, we're using new here, because if we didn't use new, we'd be executing this as a regular function and get back undefined inside of Darth Vader. Okay, so check this out. I'm going to run this. And look at that. They are the same thing, almost quote unquote the same thing. Now there are some differences and we'll see them in future videos as well. But really what's happening behind the scenes is something like this. Okay, so we're going to build on this and actually add our things to the constructor in the class and then see how that works with the function version, just so that we can see them side by side and see what JavaScript is actually doing for us behind the scenes to make this a little bit easier. Okay, so I mentioned earlier that this class thing has what's called a constructor. This is called the class constructor. And we saw here that that is a key inside the prototype that comes when we create it with a new keyword. So we can use this constructor as a function. Technically, it is a method, is what we call these things when they're inside of a class, and we can use it like any other function. Notice though that it doesn't actually have like a const or a let or a function keyword or anything like that. Within a class syntax, we don't need to actually worry about any of that because the constructs in JavaScript behind the scenes actually just turn this into an object and assign everything to their proper this values and the prototype anyways. So inside of a class, we can be a bit looser with these methods. We don't need to actually use this or const or anything like that. In fact, we shouldn't use them. This is how we should write our methods. Let's start with this constructor. Now, our class technically already has this constructor, which is why we got back an object. It was just empty. So we can actually think of the constructor already existing behind the scenes. It just looks like this. Okay, and if I rerun this code, we'll see that nothing actually changed. Okay, so by default, if you don't include the instructor, we get the default constructor, which builds the object for the class. If we don't provide it anything, it just kind of gets inserted for us. Now, in this case, we do want to be able to give our player a name, HP, MP, and items. Right? So we want to basically, if you think about this create player function, we passed in those values so that each instance of the player could have its own version of those values. This is the same purpose of the constructor function inside of classes in the OOP concept. So this constructor name is always there. We can't change it. It's built into the language. It's on the prototype of these functions already. So we can use this function and pass it arguments or build a bunch of parameters into this parameter list and then use the this value to actually assign them to the actual object instance itself. So for example, what we want to do in this case is I want to say each player has a name, HP, MP, and items. But when I call this constructor, which is what's happening for us behind the scenes automatically, I want to be able to construct this object using the constructor. So I want to assign these values to the this object, which is the this keyword in JavaScript. So I'll just write this out and then we'll kind of look at how this works together in a second. I'm going to say this.name is equal to HP, this.HP is equal to HP, this.MP is equal to MP, and this.items is equal to items. All right. Now, if you think about this, this is actually pretty much the same thing as what we're doing right here. This is literally what we are doing when we are doing that code. When we are saying this.name, this.HP, this.MP, this.items, we're assigning it to an object that's tagged as a player, which inherits from the object prototype. And then we're returning that basically. Like that's the purpose of the constructor, is to basically automate this process right here for us. Okay. So now what you'll notice is if I rerun this code, what you'll see is that the player now actually has these fields inside of it. Okay, we have name, HP, MP, and items, and they're all undefined. Interesting, right? Why are they undefined? Well, we never provided them, right? We never told them that it's Han Solo or Blaster or anything like that. So where do we do that? Well, when we construct the player object, right, we need to actually provide them here because this is the constructor for the player. You can think of when we call new player like this, it's actually calling this constructor function behind the scenes. So I can actually do this. I can actually say Han Solo, and then I can say 100, 10, and then, for example, just close this for now, maybe Blaster. Okay. So I'm saying I want Han Solo to be the name, then it gets assigned to this.name for that object for that player. 100 goes to HP, gets assigned to this.HP. 10 gets assigned to this.MP, and then this array with Blaster and it gets assigned to this.items. So we would want this player, which is pointed to by Han Solo, right, which you can see is this object right here. We want it to actually show that Han Solo has these values inside of it. So now if I rerun this code, what we'll see is that that's exactly what happens, right? That's pretty awesome. Now we have a player object with a name, HP, MP, and items that's customized to that particular player. So we created a template to make a player here with this constructor, and we can create as many players as we want, each with their own values right over here. All right. Now, I'd like to show you that we can actually do the same thing here with another player, which is our function version. Okay, so I'm going to just pass into this function name, HP, MP, and items. And inside of the function, I'm going to say this code right here. I'm actually just going to copy and paste this just to speed this up a little bit. Inside of this function, not a class, I'm going to say this.name, this.HP, this.mp, and this.items. Okay, now let's take a look at what happens if I do this and I run this code. You can see that we actually get the same thing now with undefined, right? And that's because this is effectively exactly what happens when we call the constructor function inside of a class anyways. It literally is basically doing this behind the scenes. Now, I want to actually fill this in with proper values, so let me go ahead and do that right here. And this goes into the same place, which is basically our version of the constructor function. And this is going to be Darth Vader. And we're going to maybe give Darth Vader 200, maybe 50, and then Darth Vader has a saber. Maybe Darth Vader has other things, but let's just say saber for now. And now if I save that and I rerun this code, check that out. Isn't that awesome, right? We have basically created a mini version of our class with a function. In fact, this is actually what happens behind the scenes when we are actually creating classes in JavaScript anyways. So it's really just using functions and prototypes and the this context. Okie dokes. That's pretty awesome. So let me just create another player here, just so I can show you that we are actually creating different values, since I only really created an object with the constructor function here. So maybe I'll just call it Nader, for example. This is a new player, and maybe I'll just put my name in here. Maybe I have very little HP, very little MP compared to Han Solo and Darth Vader. My items, maybe, I don't know, maybe I have my computer with me, right? I always seem to have my computer with me. Maybe let's see how that goes up against a blaster. So I'm just going to copy this code over here, and I'm going to paste it here. I'm going to replace all the Han Solos with Natter. Okay, so these are both players. They should have their own state, and changing one should not change the other. So let's see if that's true. All right, now that is pretty awesome, right? We have two players, right? Here is Natter and here is Han Solo. And then we also created our another player just to show that it can be also created using the function syntax technically with Darth Vader. Okay, wonderful. Now, we definitely want to be able to do more with classes than this, because as you can see, right, we can basically just do this with functions. Like, what is the kind of the point of all this? Why not just use functions? And that's true, right? Well, there's much more that goes on behind the scenes. Technically, there's also some small caveats between classes and functions in JavaScript, but let me go and see methods next so that we can actually see one of the most important parts of classes. I mentioned earlier that in the very beginning that for object-oriented programming, we want to be able to manage and think about state and then model interactions within and between states. But that most importantly, objects have data and code associated with them. So we kind of have the first part, right? We have this like objects have data part, right? Because if you look at our object, we have data. We're storing data in here. This is the state of a particular player at any given time, which is stored in HP, MP, name, and items. All right. But we don't really have any code apart from kind of initializing those values, right? I wouldn't really count that as code. That's just kind of the boring setup stuff, right? To deal with the state. So what is this code business? So let's take a look at methods. Now, this is really starting to get to where classes shine, and object-oriented programming in general makes a lot more sense when you actually start breaking things down into these concepts. So the only change here is this orange portion, which I've added down here, where we're adding what's called a class method. Now, I mentioned technically the constructor is a method. It's the one that comes built in, and we can actually modify it slightly by customizing it like we did over here with our player. We can also add custom methods though. So every player can have associated with it different functions, and those functions can operate on the state of that object or just do things totally different entirely. So for example, in this case, I want to associate a phrase or speak that takes a phrase to each player. And that is going to console.log out this.name says phrase. So how this would work is that once we create our player object, for example, Han Solo, just like we did earlier, now what we can do is we can actually call this method, which is a function of a class, on our class instance, which is Han Solo. So we can do Han Solo.speak and pass it our phrase, and we will actually get Han Solo says, never tell me the odds, right? So that is pretty awesome, okay? And I want to show you why this is really, really awesome when we actually code it out. So I'm going to come back in here, and I'm going to just put this in here for now, just since we have this all set up quite nicely. I'm going to add underneath my player constructor a speak method. Now notice again that I haven't added the function keyword, nor have I added const. So I can't do this. I can't do like const like s equals that. We can't do assignments like this, and I'll show you how we can do something similar to this in a second. We can't also do this. We can't say function, s is equal to something and then do something in here, right? We have to have it like this. And because JavaScript is looking for these signatures behind the scenes to actually do what it needs to do to wrap these into an object. So this is all just JavaScript syntax for classes. In fact, this matches syntax for most classes in most programming languages. So let's say we want to speak a particular phrase. And in this case, we want to do a console.log of, I'm going to use a template string. And inside of here, we have access to everything in the state of our current object. Very similar to how we would have it in a function with the new keyword and the this context. So I think I forgot what I said here. I have this.name says and then phrase. So this.name says, and then phrase. Okay, so I'm going to reach in to the state of my player and grab the name using this dot name, which is the name of the player that is calling the speak function in particular. Okay, so when we say Han Solo dot speak, the this context is going to be Han Solo, and then the this is going to equal to this dot name is going to equal to Han Solo, which is this name right here. So if I said natter dot speak, then it would be natter. Okay, so let's try this out because that's all the code that we actually need. So right under here, I'm going to say Han Solo dot speak, and then right under my name right here where I created myself, I'm going to say natter dot speak. All right. Now, I'd like you to notice a couple of things. First, of course, we want to see the actual output of this, but I'd like you to look at the property names for each of our objects, and then also the property names of the prototype. All right, let's take a look. So I'm going to run this, and let's kind of take a look at Han Solo to start, which is right here. Okay, so we have Han Solo says undefined because I forgot to say. What does Han Solo say? Han Solo says, never tell me the odds. I think it's a famous phrase. Never tell me the odds. All right. Natter is just going to say, monkeys are the best animal. My favorite animal. All right. Let's go with that. So I'm going to rerun this code. And you can see that we get, for Han Solo's case, Han Solo says, never tell me the odds. So that's coming from line 15 in my case. Right? And we can see that Han Solo is this object right here that has the state of name of Han Solo, HP of 100, MP of 10, and items of blaster, right? And then the property names for Han Solo exactly are name, HP, MP, and items. Now notice that speak is actually in the prototype for player. It's not inside of the instance for player. Right? So we're getting the property names of Han Solo here, and then we're getting the property names of Han Solo's prototype. And the prototype for Han Solo is player, right? So what we're saying here is player's prototype has speak and constructor, but Han Solo itself only has name, HP, MP, and items, which if you think about it, kind of makes sense, right? Because this function right here, or this method right here, right, is not really setting up this object state or dealing with any of the state in particular when it comes to the actual core state of Han Solo. Whether this function is on the natter object or the Han Solo object, it doesn't really matter because as long as that object has a name and we pass in a phrase, it's going to work. It's a more generic function. But each player needs to have a name, HP, MP, and items in our case, because that's what it means to be a player. All right. So we can say that the constructor exists on the prototype of player, and the speak method also exists on the prototype of player. But these properties, name, HP, MP, and items, exist on each instance of a player object. So speak and constructor are shared across all players, and name, HP, MP, and items are in the state of each instance of player. And we can see that here too, right? Natter says monkeys are the best animal. I have my own state right here, which is different from Han Solo. I have my own property names right here, name, HP, MP, and items. But then we share the same prototype, which is player, which has a constructor and speak. Okay, so let's take a look at how this would work with another player. So if we just try to do this kind of at first glance, maybe we would do something like this. Maybe we would say this.speak is equal to a function, and it's going to take a phrase, and I'm just going to copy this console log since it's a little bit long from our other speak over here, and I'm going to paste that in here. So inside of the console log, I'm going to say this.name says phrase, right? So in theory, what we can do is we can say console.log Darth Vader I don't have to console.log this actually. I can just say Darth Vader.speak. What's the sound that Darth Vader makes? Like whatever that sound is with his mask, for example. That's definitely not what it pronounces like, but let's just go with that. Oh my goodness. So I'll clear out my console here. Let's see if this actually works. And it totally does right here. It's a bit cut off by my head. So maybe I will comment out one of mine up here. I'll maybe just comment out myself, and I'll leave Han Solo and Darth Vader up on the screen. And there we go, right? So Darth Vader says, whoosh, right? But if you look at this, the difference here is that Han Solo's object instance has name, HP, MP, and items. Han Solo's prototype, which is player, has constructor and speak. But our another player class instance, which is Darth Vader, has name, HP, MP, items, and speak in the instance, but only a constructor in the prototype. So really the difference is that this .speak is in the prototype. It's not in the instance of each player. So, or another player in this case. So what we need to do is we need to move this out of each instance. Instead of duplicating it every time we create a new another player, we want it so that this is shared across all players, so that every player, no matter what, is going to be able to call speak. They don't each have their own individual function of speak. So the way that we do that is down here. I'm going to say another player dot prototype dot speak, just like we assigned to the object prototype before. And I'm going to copy this function and cut it. And I'm going to paste it right here. Forgot the F. And I'm going to get rid of this .speak inside of the another player. So if we look at this, what we're saying is create the another player function, and it's going to assign out all the state to that object of another player, which is the name, HP, MP, and items. But then inside the prototype of another player, we want to have a speak method so that every version or every instance of another player, like if I created another player, oh my goodness, so many anothers, it would also have its own version of name, HP, MP, and items, but it would share the speak from the prototype across all versions of another player. Okay. So now if we run this code, let's see if this matches up. Check it out, right? It still works, right? But notice now that the constructor and speak are in the prototype for both the function and the class. So that's pretty awesome, right? So we can think of JavaScript here as when it sees this class syntax, all of these methods that we're adding get added to the prototype of the class. Okay? They don't get added to the instances. Only when we use the this value are we actually assigning to the instance itself, which makes sense. All right. Now, I do want to kind of show one more thing in here before we keep going with this in the next videos, is sometimes what you'll see people do is they'll assign properties to the class up here, and the syntax looks slightly different. So I just wanted to show you that so you have a heads up as to what that looks like. Let's just say, for example, each of our players, I don't know, like maybe they have an age, for example, for whatever reason. Now, we could do a this.age in here and assign it to the constructor, but I can also put age up here, for example. Let's just say I have an age of 20 by default, for example. Okay, so you can't change your age, you just set to 20 no matter what. Okay, so what is this gonna do, right? Why does this even work? This looks kind of weird because this is not like const age, right? That's not gonna work. We can't do that in classes. So this is effectively the same thing as doing this right here. This.age is equal to 20. Okay, I'm going to comment that out so that we don't actually execute this code. Line 8 and line 2 are pretty much, for our intents and purposes at least, the same thing. All right, so we are assigning a property to the class instance of age and assigning it a value of 20. Let's run this code again, and we can see now that age has been added to player, and it's going to have a value of 20. So every player that we create, no matter what, is going to have a value of 20 because we didn't pass it into the constructor in this case to actually modify it. Okay, we can technically do like Han Solo.age. So for example, if I say Han Solo.age is equal to now, let's just say Han Solo is 50, right? I can rerun this, and then now Han Solo is going to have an age of 50. So it really is the same thing. It's just that the way that we initiate it is a little bit different. And if we didn't initiate it to anything, it would just be undefined. Okay, so we can kind of set up default values up here, for example, and it's a little bit easier to read than seeing all these this values inside of here, unless you really want to start assigning them to things right away, like this, that come from the constructor function. All right, Now, I hope that that was a useful video. I know we went through a lot in this video. If you did appreciate this video, I'd love it if you could like the video and subscribe to the channel. I'd love to hear in the comments as well, what did you think of this explanation of object-oriented programming as an intro? Specifically this class properties and syntax versus the new function keyword and the class methods, as well as how the prototypes all work when you put all these things together. Did that kind of make sense? Was it a bit too complicated? What we're going to do in the next video is actually go through a bunch of exercises on this so we can get even more practice, because that's really what it takes to kind of hammer these concepts home like we did with all the other videos. And then in the following videos, we're going to look at some concepts that I mentioned in the beginning that are actually going to take this idea and really amp it up, and we can actually see the true power of object-oriented programming. So we're going to see concepts like inheritance and polymorphism. We're not really going to cover abstraction too much, but we're also going to see a bit of encapsulation as well, with things like private and public and protected and all that kind of stuff, which is a lot of content to go through, but I'm super excited because this is the stuff that we're going to start seeing a lot, whether we're working with other people's code or even our own code, and where we try to model our own objects for very large applications. Okay, so I can't wait to get to the exercise videos for this one. I will see you in that video. See you later.